When you think of the laws of the universe, who comes to mind? Isaac Newton, right? Of course. But here's the thing. Newton stood on the shoulders of a giant, and that giant was Johannes Kepler. He was this brilliant, obsessive, and deeply religious astronomer who didn't just map the stars, he literally handed Newton the blueprint for the entire cosmos. This is the story of how he did it. Our whole story really kicks off with just a number. That's it, 8. It doesn't look like much, I know, but that single digit, it represents one of the most pivotal moments in the entire history of science.
So how on earth could a number that small, we're talking just 8 minutes of arc, completely shatter an idea of the universe that had been around for 2,000 years? Well, because that number, it was a mistake. A tiny, nagging discrepancy between what theory predicted and what the real world showed. It was this little crack in the foundation of everything astronomers thought they knew, and it was the one mystery that would push Johannes Kepler to tear down a worldview and build a new one from scratch.
To really get what Kepler accomplished, we've got to take a step back and look at the universe he was born into. It was a cosmos built on this incredibly powerful, really beautiful idea that had reigned supreme for centuries, and it was just completely wrong. So you basically had two competing models, but with one massive flaw. On one side, you had the old-school Ptolemaic system, with the Earth parked right in the middle of everything. And on the other, you had the radical new Copernican system, which put the sun at the center. Now, they seem totally different, right? But they both shared this one fundamental, unquestioned belief that everything in the heavens had to move in perfect circles. For the ancient Greeks, this wasn't just science, it was philosophy. It was a sign of divine perfection. And that brings us to our hero, Johannes Kepler. Now, Kepler wasn't just some dry mathematician crunching numbers. He was a mystic. He was on this deeply personal mission to uncover the divine geometry that he was sure God had used to build the universe. For him, astronomy wasn't just a job. It was basically an act of worship. So his first big swing at this was a book called the Mysterium Cosmographicum. And the idea, wow, it was wild. It was brilliant. He knew there were 6 known planets at the time, and he also knew there were only 5 perfect 3D shapes, what we call the Platonic solids. So he thought, what if God used those 5 perfect shapes as like the scaffolding between the orbits of the 6 planets, nested one inside the other like cosmic Russian dolls? I mean, it's a breathtakingly beautiful theory, right? So elegant. But here's the thing that made Kepler a true scientist. He checked his beautiful idea against the actual data that was available, and he himself had to admit that it was, in his own words, not exact. It was close, but for Kepler, close wasn't good enough. And that tiny failure, it just lit a fire under him. He became obsessed. He needed better data. And that obsession for better data led him to one person, and one person only, Tycho Brahe. Tycho was, hands down, the greatest observational astronomer of his era. He owned a literal treasure trove of the most accurate, most precise measurements of the stars and planets ever made. Their partnership was going to change the world, but man, it was anything but friendly. Yeah, this was a seriously contentious collaboration. Tycho was famously secretive and, frankly, a bit paranoid. He did not trust this brilliant young Kepler one bit, and was terrified he was just going to steal all his data and get all the glory. So instead of just handing over his life's work, he held back. And to keep Kepler occupied, he gave him the single most difficult, most annoying problem he had, figuring out the orbit of Mars. Tycho figured that'd keep him busy for a while. He had no clue he was actually handing Kepler the key to the entire solar system. And so began what Kepler himself called his war with Mars. This was an absolutely brutal, years-long campaign of calculations. He was trying over and over and over again to make Tycho's super-precise data from Mars fit into the ancient, sacred idea of a perfect circular orbit. And he tried everything. I mean, we're talking about nearly 1,000 pages filled with the most dense calculations you can imagine. He used every geometric trick he knew, but no matter what he did, he just couldn't make it work. There was always this small, nagging error that just wouldn't go away. And there it is again, 8 arc minutes. Now, just to give you a sense of how small that is, that's about 1/60th of a single degree, an absolutely tiny sliver of the night sky. With anyone else's data, he could have just brushed it off, called it an observation error. But this was Tycho's data. It was the gold standard, and Kepler knew it. He knew the data was right, which could only mean one thing. The theory had to be wrong. And this, right here, this is the moment modern science is really born.
Kepler faced a choice: stick with the beautiful 2,000-year-old belief in perfect circles, or trust this tiny, ugly, inconvenient fact from the data. And he chose the data. In his own words, those 8 minutes point the road to a complete reformation in astronomy. He abandoned the circle. He just let it go.
And by finally letting the data lead him, instead of his beliefs, he discovered the true shape of reality. He uncovered the 3 fundamental laws that describe exactly how every planet actually moves through space.
So, first law, orbits aren't circles, they're ellipses, kind of like squashed circles. It was such a simple change, but it swept away centuries of unnecessary complexity. Second, planets don't move at a constant speed. They actually speed up as they get closer to the sun, and then they slow down as they get farther away. And third, and this is the one that's just mind-blowing, he found this stunningly precise mathematical relationship, a harmony, that connects a planet's distance from the sun to the time it takes to go around it.
Now, Kepler's laws were perfect. They described how the planets moved with incredible accuracy. But they couldn't explain why. Why ellipses? Why do they speed up and slow down? Kepler had basically drawn the perfect map of the solar system, but he didn't know about the force that was driving the whole thing. He had, without even knowing it, built the perfect bridge for Isaac Newton to walk across.
So when Newton came along, he took Kepler's 3 laws not just as descriptions, but as clues. He realized that they weren't just random rules, they had to be the mathematical consequences of a single universal force. Kepler's hard-won data was the exact empirical evidence Newton needed to forge his theory of universal gravitation.
You can almost watch Newton's mind at work here, just working backwards from Kepler's clues. He looked at that second law, the equal areas one, and realized, aha, that can only happen if the force is pulling straight toward the sun. Then he looked at the first law, the ellipses, and he proved mathematically that the only way you get a stable elliptical orbit is if the force gets weaker with the square of the distance. And finally, that amazing third law, the harmony, showed him that the strength of this force must also depend on the mass of the objects. It was like Kepler had left him a treasure map, and each law was a clue pointing straight to gravity.
And that was the magnificent conclusion, the great synthesis. The very same force that makes an apple fall from a tree here on Earth is the exact same force that holds the planets in their orbits millions and millions of miles away. The rules of heaven and earth were finally united. The scientific revolution was complete. You could say that Kepler gave Newton the universe, and Newton told us how it worked.
So, when you boil it all down, Kepler's legacy isn't really just about planets and ellipses. It's about the courage to honor the data. It's about trusting a small, inconvenient fact more than you trust a grand, beautiful theory. And that, of course, leaves us with a pretty big question, doesn't it? What cherished idea that we all believe today might be just one tiny error away from being completely overturned?